So welcome everybody to the webinar Hydrogen and Power to X, organized on behalf of MAN Energy Solutions. I am happy to welcome a panel of distinguished speakers, first of which is Erik Zindel from Siemens Energy. He's the Vice President of Generation Sales, Hydrogen Leads, and he is responsible for hydrogen combustion and gas turbines, as well as for the business development around the hydrogen value chain. He has been with Siemens for 27 years and he's been working out of Germany, Spain, Mexico, South Korea, and the UK. He's been working on large fossil-fired and industrial power plants as well as renewables. Our second panelist and speaker is Tanguy from Equinor. He is the project director of the H2H Solden project, where he's delivering Equinor's hydrogen roadmap within the Humber region in the UK. He's held various positions within Equinor, such as the company's operations director in Azerbaijan, and more recently the director of the Brazilian Bacalhau project, which attained FID in May 2021. And our third panelist and speaker is Klaus Payrhuber. He holds a strategic project development position at INNIO Jenbacher in Austria, and he works on hydrogen initiatives for making gas engines ready for hydrogen operation. So my warm welcome goes out to all of you. So let's please kick off our discussions by specifying the drivers for the fast adoption of hydrogen, not only as a fuel for power generation, but also in the transport sector. Tanguy, would you like to share your view on that, please?
Yes, good morning to you, and good morning to all the participants. Great pleasure to be with you this morning. Before to answer, let's step back one second about the energy supply today. It's currently that's the challenge, is to decarbonize the whole energy supply today. And if you look at the energy supply today, it's still predominantly a molecule more than electrons. And when I talk molecules, I talk about oil and gas molecules. So these are, in addition to decarbonize the electricity production as of today, it's also to target the decarbonization of the molecule, and namely the gas. We see that consumption of our gas today can be easily switched to hydrogen, and really the hydrogen from natural gas is an elegant way to decarbonize this molecule, hence to decarbonize the energy supply as a whole. So this is really the challenge, is to decarbonize the molecules that goes into the energy mix supply today.
All right. Mr. Payrhuber, would you like to give your view on the drivers? Why do we see such a fast adoption of hydrogen engines and turbines? What are the economic and the technical drivers for that?
Yeah, good morning, everyone. We're talking about the power sector, you mentioned transport sector. There are other sectors like the industry and the building sector. So there's a huge demand at the moment for hydrogen. On the other side, hydrogen is used for a very long time in many of our industries. And it will be very interesting to see which sector will be the first adapting more to hydrogen. Hydrogen is very often used in the chemical industry, in the oil and gas industry. This will be expanded. Steel industry could be a new one, but certainly the power sector is one mid-long term, which is showing very nice perspective, moving away from or transitioning from natural gas to hydrogen.
Okay, Erik, would you like to give Siemens view to that? What are the drivers? What is driving the adoption of hydrogen, and how fast is it going?
Yes, Anja, thank you very much, and also very warm welcome from my side as well to all of you. I think the main driver for the hydrogen economy is the decarbonization, as Tanguy already explained. We need to decarbonize until approximately the middle of the century all the sectors in the economy all around the world. And the idea is a little bit to have the the sectors that are more difficult to decarbonize, like mobility, like parts of the industry that cannot simply electrify everything with renewable energy, to give them energy in a sustainable form that they can use. And here hydrogen plays a major role. And it's really about displacing conventional fuels, displacing carbon-based fuels with a sustainable hydrogen, whether it's green or blue. And with that, we can help as well the different sectors to decarbonize. And what's very important is, as we're embracing on this decarbonization route, we're getting more and more energetic connections between the sectors. We call that sector coupling. Because it will begin with the power sector providing renewable energy, either directly in the form of electricity, but as well in form of hydrogen to the other sectors. That can as well be re-electrified, so that hydrogen can as well serve as a long-term, large-scale storage of energy.
Good. You already addressed the second question, but I'd like to get a concrete timeline. So by when do we see hydrogen fueling be adopted in large quantities within the power sector? Can you go into this, please?
Yeah, maybe it's important to understand that hydrogen, sustainable hydrogen, will become a commodity. It is a green, sustainable form of an energy molecule, and can be used by every sector, depending on who has the highest willingness to pay. And we're going to see different break-even points for the price of sustainable hydrogen. And we see that in other sectors like industry and mobility, this break-even price is higher, which means effectively we can have a decarbonization of a ton of CO2 at reduced cost compared with the power sector, which we expect we're going to see a large re-electrification of hydrogen, probably only in the 2035, 2040s, when we have to go into a deep decarbonization of the power sector. Before that, we expect that most of the green and blue hydrogen will rather go to other sectors first. And we're going to see occasionally some demonstration projects, but on a long-term scale, I would rather expect the power sector to be one of the later adopters of hydrogen. We already have access to green power with renewable energy, so the pressure is less high on us at the moment.
All right. Tanguy, Equinor is actually having a demonstration project and is a frontrunner in the adoption of blue hydrogen for power generation. Could you elaborate a little bit on that and tell us about the timeline of KEDB hydrogen?
Yeah, I think I would have possibly a more positive view of the adoption of hydrogen to power. I think it's a bit, but building on the argument of different industry merging their interests. I think this is what we see certainly in the Humber region, where there's multiple industries that combined could offer a very interesting market for deployment of hydrogen. I think hydrogen to scale will allow a cluster of industrial emissions to develop common infrastructure to deploy the hydrogen faster. And we see the hydrogen to power as a step one, as an early mover actually, to allow deployment of hydrogen at scale, combined with hydrogen to other industries, be the petrochemical, be the steel possibly. So I don't see necessarily a step by step. We see a combined off-takers of hydrogen that complement each other, power more intermittent, be petrochemical, more base load demand, and possibly blending some of this hydrogen into the existing gas network. So I think it's a combination of 3 or 4 key industries that will lift hydrogen, and we see from Equinor point of view that phasing natural gas to hydrogen in the power, first blending and then 100% fuel, is really something that could be achieved in the coming decades, certainly by by 2030, we see certainly 26 is the current plan for introducing hydrogen to power in the Sultan power station, but also by 2030 having our first 100% fuel hydrogen power. So really, we see power as driving the hydrogen to scale today.
Good. Klaus, INNIO Jenbacher also has experience on coal-firing gas engines and has participated in pilot projects. By when do you see an adoption, a re-electrification of plants with hydrogen?
Yeah, I agree with Mr. Cosmao. We could see hydrogen valleys who are the first adapters, the first movers on hydrogen, where complete regions are switched away from fossil fuels completely to hydrogen very soon. And other examples could be microgrids, where small-scale hydrogen could be used very, very soon. But your question is going more to large-scale in power generation. I think going large-scale is really something in the 30s and the 40s, when we go into deep decarbonization, and then we will see large projects everywhere.
And the smaller ones, will they be faster or rather?
We think the smaller ones could be faster. As I said before, hydrogen valleys, smaller hydrogen valleys, larger hydrogen valleys, or smaller and bigger microgrids, they could be the early movers already in the 20s, beginning the 30s.
Right. Okay, now let's look at the economics of hydrogen. So we do have grey hydrogen from steam reforming around $1 per kilogram. Then we have additional CCS to clean it all up. So this brings the cost up to $1.50 per kilogram roundabout. Then we have green hydrogen produced via electrolysis from wind and solar power to $2.50 per kilogram. So the question is, should we focus on green hydrogen only, or should we adopt a more technology neutral approach to hydrogen? Tanguy, what is your view on that?
I think it's both. I think that blue hydrogen is certainly going to leverage on existing infrastructure from the gas network, our off-takers, power plant, and petrochemical. They have the infrastructure to introduce at a lower cost hydrogen. Clearly, to be blue hydrogen, you will need to capture the CO2 and store the CO2. But also beyond that, I think the blue hydrogen will actually incentivize the development of more hydrogen infrastructure, be pipelines and other facilities. So blue hydrogen will actually make green hydrogen easier to enter the market, because all the major infrastructure, the hydrogenation or introducing hydrogen in various sectors would have been done by blue hydrogen. In addition, blue hydrogen will also incentivize the development of storage possibly in cavern of hydrogen. This is something that it will be key for green hydrogen to really deploy. So the two things are not in competition in the same time frame, but I would say that blue hydrogen development will actually make green hydrogen really developed at scale. Okay. So not in competition in the same time frame.
Okay, Erik, does Siemens agree with this view, or should we go straight to green hydrogen and straight to full decarbonization?
No, I agree. It's with Tanguy. As I said, sustainable hydrogen is a sort of a commodity. So being a technology neutral always helps to develop the best solutions. The blue hydrogen may be not considered 100% decarbonized, because you always have some methane slip, and you have some additional emissions across the whole value chain. But in general, let's consider that sustainable. It depends a little bit on the location as well. Countries with access to natural gas and also the possibility to store on long-term carbon molecule will have definitely an advantage for the blue hydrogen, while other regions where we have excellent conditions for renewable energy might go the green hydrogen route in the beginning. But we see as well blue hydrogen being a little bit cheaper than green in most parts of the world. And I expect as well that blue hydrogen will be a sort of a door opener into the hydrogen economy. And then over time, we're going to see probably a very well mixture with green hydrogen maybe having the slightly higher growth rates.
So actually, your customers are preferring blue hydrogen because it's a cheaper fuel than green hydrogen. And supposedly it's
in many parts of the
quantity.
Yep.
All right. Klaus, do you see it the same? So do customers prefer coal-fired their engines with blue rather than green hydrogen?
Yes, more or less. Actually, the internal combustion engine doesn't care which color the hydrogen comes with. The molecule is always the same, but the costs are different and the sources are different, and especially the availability, I think, is different. And here the blue hydrogen could really help to ramp up a hydrogen infrastructure for many sectors, including power generation.
So does this mean that the plant is only profitable with blue hydrogen in many cases?
That could mean power plants, as an example, could be more profitable with blue hydrogen first, before green hydrogen is becoming more available and more cost competitive, and then we could switch over from blue to green hydrogen.
All right, so this brings us actually right to the industry applications of blue versus green hydrogen. I'd like to know, can hydrogen actually reduce the operating costs of a power plant? Does it make economic sense to use hydrogen rather than natural gas? Erik, do you have custom experience on that?
Yeah, yes, well, as I said, it's a commodity. What is the cost of the kilogram of hydrogen is the determining factor. We see that if we take the cost of gray hydrogen around 1.5 to 2.5 US dollars per kilogram, depending on the region, if we would take that as a reference, we still see it as a more expensive fuel compared with natural gas. So from a pure economic point of view, burning hydrogen today does not make any economic sense. If you go with sustainable hydrogen, let's say at the best locations in the world, we're already there with competitiveness against the gray hydrogen around close to €2 per kilogram. But even with that price, it would still require a CO2 certificate price of over €200 per ton to make it competitive with a natural gas power plant. So it's not something that is currently there, but obviously with the time we're going to see increased CO2 emission prices. We're going to see reduction as well in the cost of green and blue hydrogen, and it's a matter of time until it will become competitive with the conventional gray hydrogen and natural gas, obviously.
Tanguy, over to the Keadby power plant projects. Are they actually profitable running on hydrogen, or is it more a politically motivated project in the end?
I think clearly we often use the term first of its kind project. It's not the technology that is new. I think producing hydrogen has been done for 40, 60 years. There's actually around 100 million tons of hydrogen produced, gray hydrogen produced today in the world. So the first of its kind is really introducing hydrogen in the economy. And this will require government support, government incentive to make the penetration of the hydrogen first. So first of its kind is first hydrogen economy to be developed and incentivized both by the production of hydrogen, which will need to be incentivized, but also incentivize the off-takers, the power plant companies, the petrochemicals, and other refinery to introduce blue or green hydrogen into their manufacturing process or their operations. So it is a premium. It is the cost of decarbonizing the energy supply. It's a cost that will have to be either through taxes, CO2 taxes, that will have to be introduced. So at the end, it's not necessarily means a cheaper energy, but it's a decarbonized energy, and this has a cost at the end of the day.
Sure. Klaus, what is your experience on the cost and on the profitability of hydrogen? Also with reference to your plant or the plant which you helped to hydrogen co-fire in Ottmarschen.
Yeah, actually, I see it more or less the same. Making hydrogen competitive to natural gas is really a challenge today. If CO2 price is the only element that is compensating, today the CO2 price with 50, 60 euros per ton does not be enough. It's not enough. We would need significantly increased CO2 prices of above 150, 200 euros per ton. And this is not foreseeable in the next 5-10 years. So we think smaller projects like in dedicated areas where they switch completely to hydrogen, or microgrids, for example, where there's no access anymore to fossil fuel, they could transition very fast to a hydrogen power generation, providing the residual load to renewables. Because at that time, when they do this at microgrids with renewables combined, the power plant, the gas power plant, they just need to run very low operating hours, just do the balancing and just run when the renewables are not available. And this is probably much easier to use than more expensive hydrogen and completely carbon neutral.
As you just said, we cannot wait and hope that the carbon price will rise to 150 or 200. But is there something we could do on the technology side to maybe produce hydrogen cheaper, or to make the engines more fuel efficient, or that we could help from that side?
Well, ramping up the hydrogen economy will help significantly, making hydrogen production more cost competitive needs scale, and this all goes in parallel with the renewable power generation. This also need to ramp up significantly. Renewable power need to be cheap, and this goes all in parallel, And one nice thing which is very often forgotten is when we progress with the energy transition and go to more and more renewables, more and more wind and solar, the residual load is required less and less operating hours is required, So the hydrogen consumption for gas power plants will reduce over time. This will help additionally to make them providing the residual load based on hydrogen becoming more economic.
Okay, Erik, this brings us right to the technology section. What is Siemens doing to make hydrogen cogeneration cheaper? Is there a solution from the combustion side, or how could we help a fast adoption of hydrogen from the technology side?
Well, I think it's twofold. And first, we have to look at the costs of generating, transporting, storing hydrogen, which we have as well activities on. You know that we are as well in the electrolysis business. We're one of the largest market leaders in terms of hydrogen compression. But when it comes to the re-electrification, obviously the main point of view is ensuring that our turbines have the capability to co-fire hydrogen and eventually fire 100% hydrogen, while keeping emissions low and high performance figures, power output and efficiency. So those are the areas where we're currently working on. And we have significant R&D expenses currently in improving the hydrogen co-firing capabilities of our turbines, and we expect to get to 100% for most of our turbine types, all sizes, latest by 2030.
Okay, for a customer, how quickly can they retrofit their turbines to hydrogen? So the implementation, how quick is that?
Yeah, the retrofit depends a little bit whether the power plant was already designed with hydrogen in mind from the beginning or not. If it is a power plant that is already existing, where hydrogen was never part of the story, it will depend what is the hydrogen co-firing requirements. Technically, everything is possible, but if you go to very high hydrogen contents, then you need to look into things like exchange materials for fuel pipes, change electrical systems, add additional systems where you might not have space. You would need to accommodate pipes with a larger diameter because of the lower volumetric content of hydrogen, and then that quickly can make retrofit costs very, very expensive. If the power plant was already designed with a later retrofit for hydrogen in mind, then the retrofit costs are very, very small. So we can do later a retrofit with limited disruptions and limited costs, maybe even in the shadow of conventional overhauls of the plant. That's what we call the H2 readiness concept, which is currently being discussed as well with all the other manufacturers as well in the EU Turbines Association.
All right, Klaus, how quickly is it to retrofit an engine for hydrogen co-firing, and is there a demand for that?
So we have demonstrated, and you mentioned our project Ottmaschen in Hamburg. We have demonstrated that the gas engine can be converted in the field from natural gas operation to hydrogen operation. And actually, this engine can run on 100% natural gas as well as 100% hydrogen and mixtures in between. So this is possible to do that in the field. In the future, we may combine retrofits like this with a minor or major overhaul of the engine, and then the costs will come down as well significantly. To your second question, how big is the demand at the moment? I would say the interest is very big. Customers want to understand when they invest in a natural gas power plant today, can they convert it to hydrogen or other renewable fuels later? This is the most important question that comes from customers today. And this is what we're answering with our hydrogen ready concept. And we have already demonstrated that it can be done. So this is the positive answer to everyone.
Okay, Tanguy, referring to, again, back to the Keadby plants, is Equinor or is the region planning to co-fire the Keadby 2 combined cycle power plant as well with hydrogen? And also at a later stage, will this Humber region cluster be replicated elsewhere, maybe in the UK or in another country?
Yes, so clearly retrofit existing design from natural gas to hydrogen is possible up to commonly agreed around 30% blending. So Keadby 2, which is a gas-fired power plant under construction today for commissioning in a year or two times, is a potential of take of hydrogen in a blending scenario of 30%. And as was mentioned by the other panelists, by the end of this decade, having gas turbine being able to fire 100% of hydrogen by the end of the next decade. So yes, Keadby 2 power plant in the Sultan Chemical Park, Keadby 4, we see that this being one of the vector to develop a hydrogen economy in the Humber region, which could by 2030 represent about 50% of the ambition of UK in terms of hydrogen production and penetrations. I think what is really important is to see that the economic of scale is really important. Being able to have a system that is able to meet the intermittence and the flexibility of the gas-fired power plant to hydrogen, mixing hydrogen into together with storage. Storage is a key element of the hydrogen economy. And that's why if you focus on region like Humber, with a potential very high market for hydrogen in multi-industry, this is where you can achieve economic of scale, but also each industry complementing each other when it comes to the hydrogen usage in terms of the flexibility they require.
Is there anywhere in Europe where Equinor is considering replicating, or where the knowledge from the Humber region hydrogen cluster could be replicated?
So Humber is a very special area, very large CO2 emitter, very diverse industries. Through the Zero Carbon Humber partnership, an alignment of interest across petrochemical, power plant, steel manufacturers. So it's a very unique area with a unique set of industries that have all shown interest and commitment to find solutions to deploy hydrogen. So this can be replicated in other parts of Northwest Europe, being Netherlands, being Germany. Germany will be mainly steel versus power. So each region has to be seen slightly different, but I think the key to find an equivalent to a Humber region is to find a region that has multiple industry type that have different needs for hydrogen, and this in itself create the market and the fluidity of the market.
Erik, I'm sure the industry is looking at the Humber region. Did you hear customers either in the Netherlands or in Germany or northern France, where these industrialized clusters, petrochemical, steel, power generation, are coming together and they are looking to replicate the Humber region hydrogen cluster?
Yeah.
Sorry, I was muted. No, I wanted to say that in the Benelux area, we're already seeing quite a lot of activities around building up a backbone hydrogen network, and as well connecting it to an existing gray hydrogen network that is currently located in northwestern Germany in the Ruhr area. Because it's very, very important that we get the hydrogen infrastructure. Hydrogen is a very small molecule with a very low volumetric content, and in order to get it into the end users at larger scales, and a power plant is a typical very large consumer, we can only do that with the help of pipelines. We cannot work with tanks simply because just imagining a power plant running on hydrogen from tanks, the amount of tanks that we would need is huge. So we need pipeline support. We would need to integrate storage as well, as Tanguy said. And what we currently see in the market is that most of our customers are really taking the hydrogen topic very serious, but mainly with the knowledge that in the next couple of years they will run power plants on natural gas, but later eventually they will have to switch over to hydrogen, and they want to make sure that the power plant can do that at a later stage.
Okay, so now I'm coming to a roundup session. Looking into the future, Klaus, what would the industry like to have from the policymakers to embrace hydrogen? Would you like the politicians to embrace blue hydrogen just the same as green? And how can the industry work together to accelerate the adoption of hydrogen? You're muted.
Yeah, at the moment there are a lot of hydrogen projects under development. We see that in Europe, but globally everywhere. what is missing a little bit is the time frame and the implementation plan of hydrogen infrastructure and applications. Yeah, I agree. A hydrogen pipeline network is essential to making hydrogen available to end users and making hydrogen available at cost competitive prices. On the other side, we talked before, a carbon price to compensate the difference between hydrogen and natural gas is probably very difficult to achieve it in short term, especially when it comes to green hydrogen. And this is again a view that blue hydrogen could really help as a transitional hydrogen alternative before green hydrogen becomes available in larger quantities and at more competitive cost.
Tanguy, over to you. What is still missing? What does Equinor or what would the industry need for fast adoption?
I think everybody will need courage to move into this unknown. I think what we see, you mentioned what do we need to from the policymakers. I think UK has embarked in a very different route from the rest of Europe. They have clearly said that hydrogen will be part of their energy supply mix, but they have not prioritized blue versus green. They see the two really coming together, and this is very different what we see from the rest of Europe, where green has been on the top of the agenda. I think UK has shown pragmatism on that aspect. They also have worked very hard the last 2 years to provide a long-term view of their strategy, 2030, 2035. And I think for any investors, you need this long-term perspective, where we are heading. UK government has also put quite a significant amount of money to incentivize the industry to work solutions. I mentioned the Zero Carbon Humber. Other industrial cluster in UK have received funds from the government to develop solutions. I think the government approach in UK to work together with the industry, both the producer and the off-takers and the consumers, incentivize and promoting joint industry work to develop that. I think it's the way through this collaboration between public and private partnership. This is what will be needed to write the next chapter. And the UK government currently is really providing a long-term view of their ambition, and I would say they put act in their words by providing supports, by organizing the industry to meet this ambition, and it's very exciting what's happening the last 1 year in UK and the next 6 to 8 months in the ramp up to the COP26 at the end of the year. So really a place to watch when it comes to blue and green hydrogen introduction into an economy.
Absolutely. Erik, final word to you. When I hear Tanguy talking, I get the impression that Europe might have to stop prioritizing green hydrogen. So what do you think is missing for Belgium, Northern Germany, the Rhine-Ruhr region to adopt a similar project like the Humber region is already doing?
I think we need to work on both sides. It's really not about promoting one or the other. It's really we need to support sustainable hydrogen in any form. Obviously, there are some discussions about how much sustainable is blue hydrogen, what's the remaining greenhouse gas emissions associated with it. But in general, we should be technology agnostics and understand there is probably a market for both. And at the end, the hydrogen hydrogen is a commodity. The molecule is the same, independent of where it's being coming from. So it's really about we have to drive the energy transition in a way that it's workable. We know all these technologies are more expensive than the conventional ones, so we need either some sort of support or decarbonization targets, enforcement of regulation And that will create the markets, and with that we'll get sufficient economies of scale and economies of number to make all this hydrogen economy economically more viable and eventually cheaper than conventional technology.
Excellent. All right. So I'd like to thank the entire panel for sharing your time and your knowledge and expertise. It's been a pleasure to moderate this webinar, and yeah, thank you very much. I hope we will have future sessions on similar topics. Thanks very much. Bye then.
Thank you. Bye.
Thank you very much. Bye-bye.
Thank you.
Bye.
Bye-bye.